Alright, in this video I'm going to show you how to solve quadratics by a method called completing the square. The first thing you want to do is get your equation in the form ax squared plus bx equals c. So your x squared and your x term are on one side, your number, your constant, your c term is on the other side. So as I read the rules, I'm going to work out an example. So the first thing I have to do is move this 30 over to the other side, which gives me 2x squared minus 16x equals negative 30. Then you divide everything by a. So I'm going to divide everything by 2, because you want the x squared by itself, or the x squared term needs to have a value of 1. So this gives me x squared minus 8x. Now I'm going to leave a little bit of space here. I'm going to explain why in a moment. And then on the other side I have negative 30 divided by 2 to get negative 15. Now the next step is to add b divided by 2 squared to both sides. So if I take the negative 8 and divide that by 2, I'm going to get negative 4. When I square that, I'm going to get 16. So I'm going to be adding 16 to both sides. There we go. This creates what's called a perfect square trinomial on the left side. I've talked about perfect square trinomials in another video, but the reason we're doing this is we can write a perfect square trinomial as a binomial squared. In this case, it's going to be x, the variable, and then this number here, when we divide the b value by 2, that's what goes after, squared. So this trinomial and this binomial squared are the same thing. They're the same values. On the other side, negative 15 plus 16 gives me 1. The next thing I'm going to do is square root both sides, which gives me x minus 4 is equal to positive or negative 1. So basically I have two cases. One where this is equal to positive 1, and one where it's equal to negative 1. When you solve these two cases, you have your answers. So add 4 to both sides here, and I get x equals 5 for one of my solutions. Add 4 here, and I get x equals 3 for my other solution. Now this still works even if things aren't necessarily divisible by 2, even if you get fractions. And not as, well, I said divisible by 2, and okay, let me just show you what I mean. If I divide everything by 4, because remember you want x squared with a 1 in front, I'm going to get x squared minus 2x equals negative 3/4. So it didn't divide evenly, but I can still work this problem the same way. The next thing I'm going to do is I'm going to take the b term, divide by 2, which gives me negative 1, and square it. This gives me 1, and I'm going to add 1 to both sides of the equation. At this point, you're going to rewrite the trinomial as x minus 1 squared, and on the other side I get positive 1/4. Now what's interesting to know about this method is it works even if, like the b value here, let's say it was a 5 instead of a 2, and I got 5/2 x, which I had to square and do all that, it would still work. So if you end up working a problem like this and you have fractions in there, don't automatically assume you've done it wrong. Sometimes it works out that way. Alright, so back to this problem. The next thing I'm going to do is I'm going to square root both sides to get rid of the square here. This gives me x minus 1 equals plus or minus 1/2. Now I wrote out the two cases up here, but just to show you, you can take up a little bit less room. If I add 1 to both sides, I'm going to have 1 plus or minus half. So this means I've got 1 plus 1/2 and 1 minus 1/2, which gives me 3/2 and 1/2 as my solutions. So if you want to write out the two separate equations and solve the two separate equations, you can do that, or you can do it like this. Either way, you get the same answer. Okay, so the two problems I worked out here ended up having perfect squares at this step. You can do this even if it comes out to not be a perfect square or even an imaginary answer. So let's look at a couple of examples like that. So on this one, the first thing I'm going to do is I'm going to add 21 to both sides, which gives me x squared plus 16x. I'm going to leave some space to work to add my number here, and over here I get 16. Then I'm going to take my b value and divide by 2. 16 divided by 2 gives me 8, which I square to get 64. I'm adding 64 to both sides. So when I rewrite this as a perfect square trinomial, it's going to be x plus 8 squared equals 80. Now when I take the square root, this is not a perfect square, so I'm going to have to simplify the radical. I get x, I don't know why I put the parentheses there, x plus 8 equals, now I'm going to work over here, factor out the 80 as much as you can. That's 2 times 40, which is 2 times 20, which is 2 times 10, 2 times 5, and I cannot break it down any further. So, pair of 2's here, pair of 2's here. 2 times 2 gives me 4. Square root of my leftovers, which is 5, and there I go. So now I'm going to subtract 8 from both sides. This gives me x equals negative 8 plus or minus 4 square root of 5. Now because this does not have square root of 5 attached to it, I cannot combine these. They are not like terms. Whoop, I didn't mean to do that. There we go. So that is my solution. Negative 8 plus or minus 4 square root of 5. Technically it's two solutions in one. One where they're added, one where they're subtracted. Now as I said earlier, this also works on imaginary numbers, or with imaginary answers. With this example, the first thing I need to do is I need to rewrite it to where my x is on the same side as my x squared and the c term is on the other side. So I'm going to subtract 16x from both sides and subtract 76 from both sides. This gives me 4x squared minus 16x equals negative 76. Now I divide everything by 4, which gives me x squared minus 4x. I'm going to leave some room to add my number later. And then negative 76 divided by 4 is negative 19. Okay, so next step is to take your b value, divide by 2. Negative 4 divided by 2 is negative 2. Square it, and you'll get 4. Add 4 to both sides, and then rewrite. So x minus 2 squared, remember this here, this number in the parentheses here stays in the parentheses here, equals negative 15. So now I square root both sides. This gives me x minus 2 equals, well I have to simplify this. If I were to try to break down 15, all I got is 3 times 5. No pairs, I can't reduce it. The only thing I can do is take the negative and pull it out as an I. So the last step is to add 2 to both sides to give me positive 2 plus or minus I square root of 15. And because one's real, one's imaginary, you cannot add them or subtract them. So those are my 2 answers for that problem. Alright, that's it for this video. See you next time.